You might see the universe as a huge ball filled with stars, galaxies, and several other fascinating astronomical objects. You may see what it appears to be from the outside, as an astronaut could see Earth floating serenely above it. However, that outside viewpoint is not essential for the universe to exist. The cosmos is what it is. It is entirely mathematically self-consistent to define a three-dimensional universe without requiring an outside to that universe. You are pulling a mental prank on yourself when you visualize the universe as a ball floating in the void, which mathematics does not call for. Of course, it seems impossible that there could be a finite world with no space outside of it, and not even nothing in the sense of a wholly undefined mathematical concept. In reality, asking what's beyond the universe is like asking what sound does purple make? Because you're attempting to mix two unrelated concepts. This question is absurd. There is a very real possibility that our universe has an outside. However, this is not a need. There is nothing in mathematics that necessitates an outside to describe the universe. Don't worry if this seems difficult to understand. The goal of creating complex mathematics is to equip us with the tools necessary to understand ideas that are beyond our comprehension. One of the benefits of contemporary cosmology is that it enables us to investigate the unthinkable. Our cosmos began to exist some 13.75 billion years ago. Primordial light began to shoot throughout the cosmos and spread throughout the early universe very shortly after that. The universe itself was expanding at this point. After the first initial burst, the universe's inflation slowed. But since then, under the influence of dark energy, the pace of expansion has been continuously growing. In essence, the universe has expanded at an ever-increasing rate since it first began. The earliest photons that humans can observe, according to cosmologists, have traveled 45 to 47 billion light years since the Big Bang. That indicates that to give or take a few light years, the size of our observable universe is approximately 93 billion light years. All of the quarks, quasars, stars, planets, nebulae, black holes, and everything else that we might potentially view are contained within these 93 or so billion light years. Yet the observable universe only contains the light that has had enough time to reach us. Beyond what we can now view, there is a much larger universe. If the universe is just 13.8 billion years old, how can it be 93 billion light years across? That distance hasn't been covered by light in time. The answer to the question of whether we could ever travel to the boundary of the observable universe and what lies beyond is ultimately found in knowing the aspect of physics. To break this down, according to special relativity, objects that are close together cannot move faster than the speed of light, concerning one another. However, there is no such law for objects that are extremely distant from one another, when space between them is itself expanding. The distance between items is expanding, which causes them to fly away from each other at incredible rates. Not that objects are moving faster than the speed of light. This ultimately means that we could only travel to the edge of the observable universe if we discover a way to either travel at speeds faster than the speed of light, which most physicists believe to be impossible, or to transcend space-time using wormholes or warp drives, which most physicists also believe to be impossible. The size of the entire universe is at least 1,023 times bigger than the size of the observable cosmos, according to the cosmic inflation theory. We're missing out on a large portion of the universe. What precisely are we missing then? What is outside the observable universe? Unfortunately, we have no idea what lies outside the observable universe because we can't see it or measure it. However, several hypotheses explain what is beyond the great unknown. Despite seeming weird, the first concept is one of the simplest to understand. According to astronomers, the universe beyond what can be seen may be a limitless expanse of matter that is distributed nearly identically to that of the observable universe. This makes sense. After all, it is illogical for one region of the universe to differ from what we observe in our surroundings. And who can imagine a cosmos with an end, with a big brick wall waiting at its edge? Infinity, therefore, makes sense in some respects. However, infinity implies that once you go beyond the observable universe, you won't only find additional planets, stars, and other kinds of matter. You'll finally find everything that may probably exist. This implies that if this is accurate and we follow it to its logical conclusion, there is someone out there who exactly is like you in every way imaginable, as well as someone who is just a tiny bit different from you in every way imaginable. For example, one who is an inch shorter, one who was killed by a bus 5 years ago, one who is missing a finger, and so on. The sole difference between you and this other you is that they just picked their nose while you didn't. In fact, they might be watching this video right now. This idea strikes me as absurd, but it's also difficult to imagine infinity. The basis of another notion is something termed dark flow. Galactic clusters were all moving at an incredible pace of more than 2 million miles per hour in the same direction in 2008, which was a very weird and surprising discovery for astronomers. The gravitational impact of large things outside the observable universe is one potential source. As for the structures themselves, they could be literally anything. Mildly imaginable scales of astonishingly massive accumulations of matter and energy, or even strange warps in space-time that are channeling gravitational forces from other universes. We have no idea what these enormous objects could be. Notably, subsequent assessments have asserted that the dark flow hypothesis is unfounded, but this assertion is still under debate. Another approach entails a universe of universes. Some theorize that the entire cosmos might be contained in a tiny bubble in the middle of an enormous number of other bubbles. It is known as a multiverse by theorists. The theory, which is intriguing, claims that these parallel universes can interact with one another. When they do, a Big Bang similar to the one that produced our universe may take place because gravity can travel between these parallel universes. Even though the Big Bang occurred billions of years ago, there is a cosmic boundary to how far we can detect the things that make up our universe. Although the universe has been expanding for a long time, the pace of expansion is limited and can be precisely measured. The maximum distance humans can see in any direction is 48 billion light years if we extrapolate how far a photon released at the moment of the Big Bang may have traveled by today. That is the size of our observable universe, which is thought to be made up of 2 trillion galaxies that are all at different stages of evolution, beyond what we can currently perceive. However, there should be a far larger universe, the observable universe. We are now able to determine what lies beyond, and how much of it we will one day be able to perceive and investigate thanks to our best measurements of the portion we can see. According to the Big Bang, the universe was hotter, denser, and expanding considerably faster than it is right now at some point in the distant past. The universe has expanded and cooled, allowing gravitation to draw matter into clumps and create the stars and galaxies we observe throughout the universe in all directions. The universe we see today was created over billions of years ago as a result of galaxies and generations of stars being fueled by gravitational growth. We witness a universe that gives us the same cosmic tale no matter which way we turn. However, that story is partially based on the idea that the further away we look, the further back in time we are. The universe hasn't always been there, creating stars and expanding galaxies. The Big Bang and the evidence it has generated suggests that the universe had a beginning. Alright guys, that wraps up our video for today. If you enjoyed watching, please give us a thumbs up and hit the subscribe button for more.